Responding to Bill Gates' video, Innovating to Zero, regarding his one wish to produce electricity with zero CO2, produce it at half of today's cost, and the ability to scale this quickly. All the parts for this new type of generator are already mass produced. Today, they're still quite expensive, but scaling up will bring those costs way down. This generator turns copper into a fuel. It harvests the kinetic energy from the electrons in the copper atoms in the high voltage coil. One generator will consist of a 12-volt battery, one resistor, two matching distribution transformers, one matching capacitor, and one high-power semiconductor switch. The generator will use one of those distribution transformers and convert it into a sawtooth generator by pulsing 12 volts DC through the resistor, then through the primary coil and into the capacitor, and then through the switch to ground. The switch needs to be run at 30 Hz. When the switch is closed, high amp 12 volt DC will travel through the primary coil into the capacitor, and then through the switch to ground. When the switch opens, the magnetic field collapses and the capacitor fires back with a collapsing field. This process happens 30 times a second. There is no back electric motive force to fight. Every time the switch closes, a large magnetic field sets up heading towards ground. This field harvests kinetic energy from the copper electrons in the secondary coil. When the switch opens, the magnetic field collapses. This causes kinetic energy from the secondary coil to travel in the opposite direction. Energy also flows back into the battery at a higher voltage than it left. This machine really pumps kinetic energy out of the copper atoms in the secondary coil, first in one direction, then the opposite. What you need the second transformer for is to receive the high power from the secondary coil of the sawtooth generator, and this will step down the voltage to a usable level. This generator only has one moving part, which is a small fan to cool the switch. The physics of the automotive ignition system. This laboratory exercise explores the physics of an automotive ignition system used on vehicles for about half a century until the 1980s, and it introduces more modern transistorized systems. The main job of the ignition system is to supply electricity to spark plugs so that they can ignite the air-fuel mixture in the cylinder. In our experiment, we will apply concepts such as Faraday induction, RLC circuits, current buildup and decay, back EMF, step up low voltage to high voltage, transformers, RLC circuits, resonance, and transistors for switching currents. Keep in mind that whenever we speak of voltage, we are talking about a potential difference, the difference in potential between 2 points of interest in the circuit, one of which is usually what we call ground. In the process of understanding the underlying physics principles, you should also get an appreciation for what's going on underneath the hood of your car and answer the question, how do you get a 30,000 volt spark from a battery that supplies only 12 volts? The diagram in figure 1 depicts the elements of a very basic ignition circuit that provides the high voltage necessary to produce spark in the spark plug. It consists of a battery, a series resistor, the ignition coil, points which switch contacts, and a capacitor. Notice the symbol for ground in the circuit diagrams. Most voltage measurements are with respect to ground. The diagram shows the writing for the automotive ignition system. The way it produces 30,000 volts AC from a 12 volt DC input. They call this a RLC circuit or a sawtooth generator. The way distribution transformers are built and wired is very similar. These transformers today are only being used as step-down transformers. They receive high voltage from the grid and the transformer steps it down to usable voltages. Examples: 120, 240, and various other voltages used for industry. You can pick a pair of distribution transformers, any size you want. As you go up in size, you will have to use more substantial 12-volt batteries, maybe even more than one. They need to be wired in parallel. You take one of the transformers, run the 12 volts DC through a resistor, then through the low voltage coil into a capacitor, and through the switch to ground. The switch needs to be run at 30 Hz. Your generator will produce a 120 to 240 AC at 60 Hz, the same as you get from the grid. The new switch that makes this possible is an IGCT, which is Integrated Gate Commutated Thyristor. You can get these switches in lots of sizes. What this generator does is very efficient. It magnetically strips kinetic energy out of the copper atoms in the secondary coil at very high speeds. This generator's BMF, back electric motive force, is collected as power out. This implosion equal to the power from the explosion of the magnetic field. The only difference between those actions is that they pump kinetic energy in opposite directions out of the secondary coil. I am now going to introduce to you the innovator of this new type of generator and the author of this document, my father.
Thank you, Brian. Hello, people. My name is Michael Joseph Harrison. I am 58 years of age. I live in Richmond, British Columbia, Canada. I am the innovator of this generator and the author of this document. I've been working on this for 30 years. With this publication, I have turned this technology into public property, and anybody on the planet can build these. If you're going to build one of these, you should have a strong background in the electric power technologies and know how to handle it. This machine can be very dangerous. I take no responsibility for your actions or injuries. Proceed with caution. Thank you.